Yeah, so first of all, like I really enjoy your work, man.
Thank you very much. That's very nice to hear, and appreciate the compliment. So hopefully, it means that the work that we're doing is having an impact, for those that work in the field, which is really, really important to us because it's a practically applied profession, isn't it? So thank you.
Yeah,
I mean,
learn a lot, and I think it definitely will help me and some of my friends grow as a performance coach. And today's question is based on the things I learned from the article, besides the article and the some other art paper you did, and some of the question would be came from a sports science lab I work with in Taiwan, and they enjoy your article too.
oh, fantastic! That's the sort of stuff that we want to hear. That's great. And well, listen, I'll do my very best to um, answer those questions and to make it as easy and digestible as possible for you guys to understand.
Cool. So before those questions, can you like introduce yourself a little bit about your background and why you focus on why you choose to focus on these kind of like jumping assessment?
Yeah, sure, absolutely. Okay, so for anyone who's not sure, I'm Chris Bishop, and a little bit of background about me. I'll try not to take too long. Um, so I guess I've always, I think everyone always starts off by saying the same thing, which is I've always had an interest in sport, and I have. Um, but actually, I guess if I go to when I was 18 years old, I'm 40 now, so I'm an old man. But if we go to when I was 18, I actually studied geography for my undergraduate degree. So I didn't study sport, but I finished my degree and then um, kind of realized that I'd like to, work in sport or health and fitness. And I went and worked for quite a big commercial gym company called David Lloyd here in the UK. And I went and did all the NASM, National Academy of Sport Medicine qualifications. So the CPT, the performance enhancement specialist, the corrective exercise specialist. And I worked at David Lloyd for a number of years. And then in my final sort of 2 to 3 years at David Lloyd, I was also hired as a performance consultant for a professional football club here in the UK. And that was my first taste, if you like, of working with athletes, and I kind of wanted to do that more. So in 2009, when my work with the football club stopped, I went and worked for a private healthcare company, and my role was to primarily focus on strength and conditioning for that private healthcare company because it was a similar model to Exos, but much, much smaller, right? It had a healthcare and it had a performance side of the business. And I focused more on the performance side of the business. I then studied my master's degree in strength and conditioning in 2011 at Middlesex, where I am now. And I studied under Anthony Turner, who still works with me now. And then once I finished my master's, Anthony invited me in on like a lectureship. So it's like an internship, but in a university. And it gave me the opportunity to do some teaching, okay, on his master's degree and for the undergraduate degree. I did that for a couple of years. And then in 2014, a full time lecturer role came up at the university in strength and conditioning, and I was very fortunate enough to get that role. I've been at the university ever since. In 2016, I took over from Anthony to run the Masters, which I still do now. And I am also the director of programs at postgraduate level, which means I run the master's degree in strength and conditioning, but I oversee all the other master's degrees as well in sports. And I suppose from a research perspective, to kind of answer the last part of your question, I guess I had I had a good 5 years working for that private healthcare company before I joined Middlesex, which is why a lot of my areas of research have centered on things like asymmetry and limb differences and things like that. And I suppose, given one of the goals of rehabilitation is to restore capacity to injured limbs, that's probably where my inherent interest in things like asymmetry has come from. And I suppose more recently, in the last few years, I've had a sort of more increased interest in just all things jump assessments, because we use them so much. And it's about, my interest lies in trying to extract meaningful information from jump assessments, particularly when we conduct them on force plates, when it can be really difficult to know what we should be monitoring, because there are, 100, 200 metrics that we can get from a force plate when we do a jump test, and we can't monitor them all. So it becomes really, really difficult to know which ones we should monitor and why. So my interest is in trying to translate some simple but effective messages around our jump assessments and what we should be monitoring and why, so that information becomes more accessible to practitioners worldwide.
Cool, man. To be honest, actually, I think it's like probably a few months ago, I did a podcast with Anthony Turner.
Right, great. Okay.
And and I also did one with his student right now. I think it's Taylor.
Yeah. Tyler.
Yeah, Tyler. He's
Yeah,
also
Tyler's.
from Taiwan.
That's right. Yeah. That's right. So I'm Tyler's second supervisor for his PhD.
Ooh, that's cool. That's cool.
Yeah. Nice.
So first of all, for like all those assessment or all those movement, why focusing on like counter movement jump?
Yeah, I suppose there's a couple of reasons really. The answer's probably quite brief actually. I think that, why do we use any test or any assessment? Well, we would probably use a test because the needs analysis of the sport or the demands of the athlete would tell us it's an important physical capacity to develop. And we often use jump testing because it's very, very simple, time efficient assessment of lower body power or lower body jump performance. So there's a practical reason, right? Which is, we can do jumps very, very quickly. We can gather some data and it doesn't take lots and lots of time and effort to do. But that on its own is probably not good enough. I also think we need a biological basis to include a test. And jumping is often used because it's a really, really good proxy measurement for other KPIs, right? And if you look at the relationship between counter movement jump height and how fast someone runs, or how quickly they complete a change of direction speed test, the R values, the correlations are usually quite strong. And they're always negative, right? Which usually means the higher I jump, the faster I run, because the desirable outcome for jump height is the larger value, but the desirable outcome for a speed or change of direction speed test is the smaller value when your metric is time. Does that make sense?
Yeah, of
So
course.
They're simple, they're time efficient, but they're also quite strongly related to other independent measures of physical performance. But I guess the last reason is, well, why the counter movement jump specifically? Because we could choose a squat jump or we could choose the drop jump as well. I think the problem with the squat jump, and it's a paper from 2008, which Jeremy Shepherd showed really, really well, is with the squat jump, we often get small amplitude counter movements on the force trace that are actually not visible to the naked eye. So it looks like it was a purely concentric jump when actually there was a small counter movement. And the reason you can't see that is because, remember, a counter movement jump starts with an unweighting phase. Yeah, so we can't see that with the naked eye. So what looks to be purely concentric with a squat jump often actually isn't. And then for something like the drop jump, I think it's just a completely different skill. It's measuring something else, particularly if our emphasis is on being quick off the floor and reducing ground contact time. That's probably measuring a different capacity, really. And then the final one would be, well, why don't we use the broad jump or the standing broad jump, the standing long jump? And again, we're now working in a somewhat different plane of motion. And whilst that is some would call that a horizontal counter movement jump, it's probably giving you slightly different information as well than jumping purely vertically. So I think there's the summary of that would be, it's simple, it's time efficient, it's related to other measures of performance. It's definitely, you can more easily conduct a counter movement jump compared to a squat jump without changes in coordination patterns. And then when you start comparing it to the broad jump or the drop jump, they're probably measuring different skills and capacities.
Cool, love that. So in the article, you mentioned that for those metrics, you divide it into like performance metric, neuromuscular fatigue, and for those return from injury. So how exactly do you divide it each, like what metric should be on performance side and what should be like probably physical therapist should focus on these metrics. How do you divide these?
Yeah, it's a good question. I think I don't think the answer is an exact science either. I think there's two overarching points that might help to guide practitioners as to which metrics they choose. Right, number one would be when it comes to performance. I think I said at the beginning, why would you choose a test? You would choose a test because there is a biological basis for including it. And that biological basis is, does the test link back to performance in some way, shape, or another? Now, typically, there's two ways to assess whether something links back to performance. It's what's the correlation with another measure, or is that test measure sensitive to change? And let's say after an intervention, right? When it comes down to neuromuscular fatigue and injury, I think it's somewhat the same answer, but those two aspects of what we're tracking, what we're monitoring, I think are just more down to sensitivity to change on their own. So what I mean by that is, if I'm interested in using the counter movement jump for neuromuscular fatigue monitoring purposes, I've got, 200 metrics that I could monitor. Which ones are more likely to show larger change when my athlete is in an acute or chronic fatigue state? If injury is my focus, which metrics are likely to show the biggest reduction in capacity when my athlete is injured? So when we get to performance, I suppose I focused a little bit more in the article on just the associative analysis, the correlations. I wanted to know which metrics consistently correlate quite strongly with strength, or how fast you run, or how fast you do a change of direction speed test, something like that. These are typical physical capacities that we routinely assess in team sport athletes. And it seemed to me that typically our more propulsive-based metrics were more strongly correlated with strength, speed, cod speed. So those were your metrics like jump height. I think impulse or relative net impulse is an important metric because impulse is the metric that determines how high you jump. Yeah, that is the defining metric that will determine how high you jump. But also remember that things like power are obviously very, very important as a metric. I think we've got a little bit too focused on whether or not we're measuring mechanical power or a different form of power in recent years. And everyone's got a bit obsessed with, is power really power? I think we just need to have an understanding of what mechanical power is. And to be honest, power is still a very important metric. And we've got a bit too preoccupied with what it is and what it isn't, in my opinion. Power is always very strongly correlated with these independent measures of performance. And that's because power is just force times speed. So we know that everything is underpinned by force production in sport. And we know that the faster you do something, the likelihood is that will give you a competitive advantage over your opponents. So if things are determined by force production and they're determined by force production at speed, power is always going to be important. Okay, so I think we've got too focused on what it is and what it isn't. It's an important metric and it's always strongly correlated to speed, cod speed, things like that. So for performance, I think some of our relatively simple metrics are always going to be important. Jump height, peak power, force, and impulse, because that helps to explain how high someone jumps, which is our outcome measure. When we go to neuromuscular fatigue, remembering that this is probably more about sensitivity to change, I think the main thing for me was looking at the literature, which has either tried to assess sensitivity to change in counter movement jump metrics after either competition or after simulation, like simulated competition, or after a specific, high intensity exercise protocol. And Rob Gathercole's done some really, really nice research on this. And this list isn't exclusive, but it seems to me that time-based metrics on the force time curve seem to be quite sensitive to change after acute fatigue. And I think if you think about that logically, some of Rob Gathercole's research has shown that athletes can be tired, athletes can be fatigued, and they can still jump almost just as high when they're fatigued. They just change their jump strategy to do it. So let's say an athlete jumps 40 centimeters and their time to take off is 0.7 seconds. It might be that when they're fatigued, they still jump 40 centimeters, or maybe only a tiny bit less, but they take 0.85 seconds to do it. So they take longer to prior to takeoff, and that gives them more time to produce more force. And when we remember that impulse is the metric that determines how high you jump, if an athlete is fatigued, they've just produced more force over a longer time period to achieve the same jump height, which is what they need to do when they're tired or when they're fatigued. Does that make sense?
Yeah, of course.
So, I think typically our time-based metrics or anything that contains time will probably be important from a neuromuscular fatigue. And we selected a few individual time-based metrics in that figure, like time to take off, phase duration, time to peak power. But other metrics like RSI mod, which is jump height divided by time to take off, would also work because it's got a time-based element to it. Impulse would actually work as well because it's, force times time. or force times phase duration. And you can, of course, break impulse up into, propulsive and braking impulse. So because they have time-based metrics, because impulse has time-based components to the metric, that would also work as well. So I think typically time-based metrics are important for neuromuscular fatigue. And then when we consider injury, well, if it's a serious injury, then one limb is either incapacitated or has reduced capacity. So I think it stands to reason that we would look at between limb differences in output or capacity, which is where asymmetry comes in, because one limb has reduced capacity, and part of rehabilitation is giving that limb or restoring capacity to that limb. I also think another thing that is important is if we're going to use jump testing as a proxy measurement, we should consider which metrics might relate best to the mechanism of injury. And when you look at some of the video analysis data in football, we know that landing awkwardly from a jump, particularly on one leg when you've had maybe contact in the air, against an opponent, that can be a cause of injury, causing things like increased knee abduction moment because you land on one leg and your center of mass is over here, right? And that can cause knee injuries. So I think if we know that, or if we know what the mechanism of injury is during landing, we should probably choose metrics that relate as closely to that mechanism as possible. So I think that's where things like landing force, landing impulse, and actually asymmetry of any of those metrics that you choose will be important. Naturally, how high you jump could still be important for injury, but obviously if capacity is reduced, then we're probably also interested in force production, because force multiplied by the time that it's produced over will ultimately determine how high you jump. So if they're jumping less high, are they jumping less high just because they're producing less force or because they're moving slower? And I think things like force production, landing base force, landing impulse, asymmetry, those type of metrics will explain whether capacity is reduced, and they relate to how the injury happens. When something like a team sport athlete or a football player lands from an awkward jump. So hopefully that makes sense.
Yeah, of course. So, when I read it the first time, and there's some like I was I was eating dinner, and the first thought after I finished the three performance and neuromuscular fatigue and land and return from rehab, the first thing that comes to mind is that did you divide it based on concentric and iso and eccentric? Is it how I don't know, is it how that view it?
Yeah, no, it's a good question. I don't think I consciously did that. No, I think that we've looked at a number of different propulsive and braking or concentric and eccentric based metrics in jumping before. It does seem to me that your propulsive or concentric based metrics like jump height, peak force, peak power, those tend to be the ones that relate to performance better. So that gives us a tick for those three, right? Like I said, when it comes to fatigue and injury, I think it's more just about sensitivity to change. And it seems to me that particularly from an injury perspective, perhaps some of your more braking or eccentric based metrics would be more sensitive to change than the propulsive metrics. And actually, there's a physiotherapist who works out in Aspetar called Rula Kotsifaki. And she's done some fantastic work relating to single leg horizontal and vertical jumping. And Rula has done a couple of very big papers in the British Journal of Sports Medicine, and one of them showed that the single leg hop for distance test is not sufficient enough at detecting knee deficits, during injury rehabilitation. So when you think about that, it's a different test and it's a different skill, I know, but how far we jump is our propulsive-based outcome measure. And we've routinely seen literature now that shows that athletes can achieve the same outcome measure, but just change their strategy to do it. So I think understanding whether a deficit still exists between limbs probably comes down to which metric you choose. And I think the safest thing to do is to go, well, if I monitored 5 or 6 different metrics, if this one is okay, and this one's okay, but these 3 or 4 are not, probably the safest thing to do is make sure that every metric has restored capacity before an athlete goes back. Whereas if you only rely on an outcome measure and the data says, oh, the athlete's good to go, but actually your braking or eccentric based metrics show really, really large deficits still, not only are they more sensitive to change, but you're potentially sending an athlete back to compete when they're not ready, particularly when you think about all the braking forces and eccentric actions that are required in team sports when you sprint, when you change direction. So I think that's probably why braking and eccentric metrics are important for injury. It just seems like time-based metrics are important for fatigue, and it certainly seems like propulsive metrics are more important and relate to performance markers. So I didn't consciously do it, but it does seem logical that way when you talk about it out loud.
So since you already gave us how to some metrics, you divide it into performance, neuromuscular fatigue, and return to play. And some of the performance side of metric is kind of like output based. So does that mean if we want to increase our jump heights or increase our sprinting speed, is should we be more focusing on pure concentric phase of training?
No, I don't think so. I think how high you jump is, remember, when we're doing jump testing, whether it's a counter movement jump or a drop jump, what we're assessing is how effectively we can use the stretch shortening cycle. And the stretch shortening cycle is ultimately, whether it's slow or fast stretch shortening cycle, it's effectively a measure of how we can transfer potential energy into kinetic energy, right? So if we need to store potential energy before we can transfer it to kinetic energy, then that tells you the importance of the eccentric phase of movement prior to the explosive concentric phase of movement. So I don't think we should only focus on concentric. I think that would definitely be a mistake. I think that if we understand about that effective transition from eccentric to concentric movement, the argument is probably that both are just as important as each other in training, and that when you want to transfer that benefit into increased jump height, it's about making sure that that smooth transition from eccentric to concentric is literally as smooth as possible. So I think they both have their place, undoubtedly.
So that also works with change of direction and sprint speed, right?
Yeah, absolutely. I think that's important for any test or any movement pattern that utilizes the stretch shortening cycle. Jumping, sprinting, changing direction, they all utilize the stretch shortening cycle to some degree. the very notion of that is we have to stretch and then shorten our muscles, which would tell us that we have an eccentric and a concentric portion of movement. So they're both just as important. I think the challenge is figuring out whether our athletes have a relative strength or weakness at eccentric or concentric based movements. And that's probably where things like normative data and comparing our scores within squads is useful, but also perhaps, doing movement screening and looking at the quality of movement. So for example, someone could have a reasonable counter movement jump technique, but when you ask them to do a drop jump, step off a box, and you give them all that free energy when they fall, and then their knees buckle on impact, before they take off again, we can see that they're leaking energy everywhere, during ground contact in the drop jump assessment, but not for the counter movement jump. And maybe that then informs us that actually we need to focus on, or we need to carefully plan what plyometric training we do so that they can handle, greater load and stress and strain.
Cool, man. I know I put you in a hard, difficult position to answer that one. Sorry for
No,
that.
that's fine. No problem at all. No problem.
So I read the other article about like drop jump versus like counter movement jump. So uh besides counter movement jump, if we're gonna discuss like drop jump, is there like certain metrics we're gonna be focusing on?
Yeah, I think the main thing for me, I had this jump framework paper last year, which was just a suggestion on how practitioners should consider choosing metrics as well. So this recent paper about selecting metrics was just a slightly different perspective, and I think both are probably valid, right? The original jump framework paper last year suggested that the metrics that we choose probably need to link together so that we have a better chance of using all of the data concurrently. So I'll give you an example. It's quite possible that when we track jump scores between test sessions or after an intervention, jump height doesn't change, peak power goes up, but RFD might go down. And that's because power will only explain about 60% of jump height. It will only explain about 60% of the variance of jump height. And the relationship between RFD and jump height it is actually about between 0.4 and 0.6, I think some of the literature says. So it's quite possible that one metric doesn't change, one goes up and one goes down. And if I was your boss at work and I said, right, so we're tracking jump height, we're tracking peak power, we're tracking RFD, and you did your testing, and I went to you, did the athletes get any better? It would be really difficult to know what to say to that, because we'd have to be either really selective about what metrics we decided to say, yes, they got better at, or I would probably say, honestly, I don't know, because, one metric went up, one went down, and one didn't change. And the reason for that is because actually those metrics don't necessarily link together that well. So I'll give you two examples in the counter movement jump where you could link metrics together. So one is in the paper, right? And that's where there's been an increased interest in, modified reactive strength index, RSI mod, in recent years. That is calculated as jump height divided by time to takeoff. And I think that for any ratio metric, a ratio being one value made up of two component parts, if you're going to monitor RSI mod, the second and third metrics select themselves. You have to monitor jump height, you have to monitor time to take off, because if you're tracking a change in RSI mod, and let's say scores go from 0.57 to 0.64 in RSI mod, you don't know why RSI mod has changed. RSI mod could have changed because one athlete jumps higher and does it in the same time frame, or they achieve the same outcome, they just do it quicker. There's multiple ways for RSI mod to change, and you don't know why RSI mod changes unless you track the component parts. Similarly, if you take a metric or any time-based metric on a forced time curve, so time to takeoff, you could see that time to takeoff started at 0.8 seconds, and next time you test, it's 0.74. And that represents a meaningful change, for example. Now, assuming that jump height hasn't reduced and they're achieving the same or better outcome in less time, that would be considered a good thing. Yeah, we got the same outcome more ballistically, or a bigger outcome more ballistically. That's a good thing. But we don't know why they're taking less time to do it. And that's where a metric like counter movement depth would come in. And the correlation between how deep you dip on the counter movement and the time taken is very strong. It's usually above 0.9. So you would see most likely that if they took 0.8 seconds to do the jump, and then when you retested them, they take 0.74 seconds. If you monitored counter movement depth as well, you would note that the reason that we've seen an improvement in time to takeoff is because they don't dip as low. And you can see now I've got jump height and time to takeoff, which explain RSI mod. I've got counter movement depth, which explains time to takeoff. So our metrics link together, and we stand much less chance of falling into the trap of jump height, power, RFD example, which we don't want to do. Another example, if you wanted to use different metrics for the counter movement jump, would be, we didn't put this in the paper, but it would be another 4 metrics that work together. Jump height, net propulsive impulse, yeah, mean force, phase duration. So impulse is the biomechanical variable that explains how high you jump, but impulse is force times time. So you need to monitor mean force and the length of time in that phase to explain why impulse changes. Does that make sense?
Yeah, of course.
Yeah. So I think when we choose our metrics, we need to think about them wisely and think about them within the context of, do they relate together? Do they relate to performance? And are they sensitive to change? And I think the key thing is, and the challenge is linking your metrics together, all within the purpose of, am I monitoring for performance, fatigue, or injury? That's quite a tough thing to do. But I think, we've given 2 different perspectives on how you can choose your metrics now. And hopefully people can consider what is right for their context. And I suppose just finally, for the drop jump's exactly the same, right? Everyone monitors RSI. It seems to be the metric that everyone wants to monitor, which I actually don't really agree with. But RSI is also a ratio. It's calculated as jump height divided by contact time. If you want to understand changes in RSI, you have to monitor the component parts because they are what create it. Again, if ground contact time went from 0.21 down to 0.18, great. They're faster off the floor. So they're probably acting, they're quicker, but you don't know why they're quicker. So if you monitored stiffness, you'd be able to understand that as stiffness goes up, that's the reason why ground contact time has reduced, because they're getting less displacement in their hip knee joints, which means they are able to get off the floor quicker and spend less time, which is why the time component reduces. So I think that's definitely something for us to consider, which is, do our metrics interlink, whichever jump test we use, and how do those metrics relate to performance of some kind? But the key for me really is, never acting on data from a single test session. I think we need to get data over more than one test session before we decide that a metric is either great or useless.
So how like how many sessions you're gonna or like how many data you're gonna collect before you
Yeah,
think?
I think it depends how you use jump testing, right? I think if you we can look at changes or true change in our jump metrics after phases or blocks of training, like 4 weeks, 6 weeks, 8 weeks, 12 weeks. But we can also use jump testing weekly for monitoring purposes, can't we? And I think that I think it's the answer to that is I would probably decide that a metric is useful or not useful after maybe a couple of blocks of training, because training blocks will have different emphasis, right?
Yeah.
If one training block is focused on pure strength, we might find that force-based metrics will increase during a jump, but time ones don't. Then we might find if our next block of training has a bit more focus on power and speed and velocity of movement, we might find that our time-based metrics change more. So we probably need to have a few different blocks of training before we determine how sensitive a certain metric is to change, if that makes sense. I definitely wouldn't get rid of a metric from weekly monitoring. And that's because when we do weekly monitoring, we haven't had enough time to induce adaptation. So you'd be getting rid of a metric, but not giving it enough time to showcase its sensitivity to change.
Yeah, love that. Love that. So, recent years there's like more and more focusing on like eccentric training and like isometric training. So before I read the new article you just published, I thought there's gonna be some like peak eccentric force or like peak force on the performance side stuff. Why isn't there like
Okay, so we've got I think we put down peak or mean force for the performance side, but we didn't do an eccentric based force metric. And I think our experience, and it is primarily anecdotal experience really, is that our braking or eccentric based metrics, they tend to be a lot noisier and less reliable. You know, we've got quite a lot of data to show that the consistency or the variability of braking or eccentric metrics is the variability is much higher, or the consistency is worse for braking or eccentric based metrics compared to propulsive based metrics. So we start seeing, you know, typically a propulsive based metric might have a coefficient of variation of 4 to 6%. But actually, some of those eccentric based metrics are often much higher than 10%. And I think the problem when you have a CV or a typical error that's quite high is that you now need to find a really, really large change in that number for that change to be considered real. And that's the sensitivity to change aspect, right, of the monitoring process, where if I have a CV value of 15% or 18%, well, if I'm looking at retesting 6 weeks later, how likely am I to find an 18% change in a metric after only 6 weeks? The answer to that is very, very unlikely. So if the noise in that metric is quite high, then I'm increasing my likelihood of not finding meaningful change or true change. And if I don't find true change, and every time I test, the change is less than the error of the test, then the metric isn't really giving me any useful information. Does that make sense?
yeah, I love that. Love that. So last question, okay? So for
Sure.
all those like metrics, for all those data, uh, each and every time you test an athlete, like how many jumps are you gonna let the athlete do to collect the data?
Okay, yeah, fine. Yeah, I think there's different sort of different perspectives on this. And again, we've always in our research made sure that uh, our warm up is very, very thorough. And the warm up also contains practice jump trials, probably a minimum of 3 practice trials at sort of roughly 50, 70, and 100%, or 60, 80, and 100% of their perceived effort levels. And then I think you, assuming that you've warmed them up well and your instructions are clear and they understand what they're doing, you should be able to get reliable data in 3 jump trials. Sometimes you can even get reliable data in 2, but I do think that depends on the metric you're monitoring. And I think as long as your warm-up protocols are good and solid, you should be able to get reliable data in 3 jump trials if you give them sort of 60 to 90 seconds rest between trials.
Yeah, love that. So, if there's like coaches and therapists are interested in what we are talking about today, where can they reach out to you? And is there like in the future, is there like some interesting project you're working on right now?
Yeah, no worries. So I guess the easiest thing to do would be to just email me if you wanted to get in touch. My email is c.bishop at mdx.ac.uk. Happy for anyone to email me if they want to. Projects, well, primarily Anthony and myself are doing quite a lot of PhD supervision right now. We've got PhDs going on in a number of different topics, but related to this podcast, one PhD we've got going on from a Chinese student called Jason, who came to us from Loughborough. He's doing some fantastic work. We're looking at his whole PhD is around the counter movement rebound jump. So where you do jump, jump, yeah. So and the reason is we're trying to determine whether or not the counter movement rebound jump can give you the same information as a counter movement jump plus a drop jump. So, you know, is it more time efficient, and can it give you the same information, knowing that data collection in sport is very time and resource finite?
Yeah, so when will that be launching? When you guys gonna launch that?
So Jason has started. We've just got a we've got his systematic review that's under review in sports medicine, which is all about the different ways that you calculate jump height. You know, so looking at the impulse momentum methods, okay, and all the different ways that you can calculate that. Jason is just about to start doing some pilot testing, okay, using 3D motion analysis, force plates, etc. The first thing we plan to do is to try and establish whether or not the counter movement rebound jump test is first reliable, a bunch of different metrics. We then want to establish, do the comparable metrics in jump 1, are they similar to the counter movement jump? And then the metrics you get from jump 2, are they similar to the drop jump? We'll then look at the association between those counter movement rebound jump metrics with other measures of performance. And then lastly, we hope to be able to run a bit of a training intervention study to, again, assess their sensitivity to change. So it's always got a relatively similar format and structure to some of these PhDs, where we first establish whether something is reliable. We then establish whether it's related to independent measures of physical or athletic performance. And then we assess its sensitivity to change. And that that structure and that format helps us to determine the utility and meaningfulness of a test.
Yeah, love that. So that's all the question I have for today, okay? Appreciate
Okay,
it for your time, man.
no problem at all. Thanks very much for having me on, okay?
Yeah.